Hi everyone, I'm Sandamali from University of Washington in Seattle, and my research is on fast radar imaging. How many of you like that long line at the airport security? You have to remove your shoes, take off your belt, and then go to the scanner and stand like this. So this scanner uses radar signals to image your body. And then the security person says, okay, and we get the results in almost real time. So what's stopping us from getting results even faster? The problem is, if we want images really fast, we are not going to get good quality images. Because image reconstruction is a computationally complex process involving lots of data. So at the airport scanner, the thing that goes swish, swish around you takes a lot of measurements at a lot of positions. At each position, it transmits a signal, which gets reflected off your body, and the reflections are collected back. And the data to be processed is too much. So in practice, we rely on approximations and sacrifice the image quality. If we want good quality images, like the image on the top right, which is from the movie Total Recall, we have to wait a long time to get the image. Okay? So can we obtain images faster and still have high quality? This is the question I'm asking. In my research, I have developed an approach which we call the partition inverse, where I partition this huge problem into small overlapping sub-problems and solve them separately in parallel. Okay? In one of the experiments we did in the lab, we imaged this small balloon dog on screen, and you can see the result we got on the bottom right. And we compared this with the commonly used approximation approach called the match filter. With the match filter, it took us 3.5 hours to get this image. And with my approach, we could do it in less than a minute. And since we are not using any approximations, we were able to improve the image quality by 24%. So now we have an approach which is faster, which gives us better results. So we are one step close to the future vision. And as the next step, I'm working on how to reduce the scanning time so we can eventually get there in the near future. Thank you.